Okay, we're going to go over some of the problems from today's isotope practice sheet. So we're going to start with number one. Number one, it's talking about the element fluorine, and that is capital F, okay? It has a mass number of 19, so according to isotopic notation, that goes here. It wants to know how many protons, neutrons, and electrons there are, okay? So if you look on the periodic table of the elements, you can see that fluorine is number 9. So we know that that based upon what these numbers mean, that's the atomic number. So that goes here, and the atomic number is the number of protons. So 9, okay? And in a neutral atom, the pluses equal the minuses, so there must also be 9 electrons. And in order to determine the number of neutrons, all you do is subtract these two numbers and you get 10, and that's the number of neutrons. Okay? Let's look at number 2. Number 2 is asking for zirconium-94, okay? It's an isotope of zirconium, and the atomic number is 40, all right? So, and they're asking for the subatomic particles. Well, what number 1 just showed us is that 94, if you subtract 40 from that, you get the number of neutrons. 40 is the number of protons. Neutrons is 54, and if there are 40 protons, there have to be 40 electrons. So that was number 2. Number 3. It's an unknown element, so it's going to be X. And it has a mass number of 112 and 64 neutrons. That's all we know, okay? So if I subtract 64, so the number of neutrons is 64, protons, electrons, okay? 112 minus 64 is 48. So that's the number of protons that I have. And again, number of pluses must equal number of minuses, 48 electrons. But we want to know what X is. So we would have to look on the periodic table for number 48, and that is cadmium. Is X, okay? Let's look at number 4. Number 4 says, also X. It has a mass number of 198 and 78 electrons, which means there are 78 protons, which means the atomic number is 78. So 78, neutrons is not asking for, but we can still do it anyway. Electrons, 78, 198 minus 78 is 120 neutrons. And if you look on the periodic table for 78, it is platinum. Okay, platinum. Some of you might have that for your project. All right, let's move on to the bigger problems. Number 5 is asking you to calculate the average atomic mass of the gallium isotopes. So gallium-69, you can either write it like this, or you can put the mass number up there. It doesn't really matter, okay? Probably get used to doing it like that. So you've got 60.108% of gallium in nature is that isotope, gallium-69. And the mass is 68.926 AMUs, atomic mass units. And then you've got gallium-71 with 39.892% of gallium in nature is that percentage, and then its mass is 70.925 AMU. Now, in order to determine the average atomic mass, that's the mass that you see on the periodic table, okay? Atomic mass is this. This is the atomic mass of that isotope. This is the atomic mass of that isotope. I want the average atomic mass of all gallium so I can put it on the periodic table, okay? So I'd simply multiply this number times that number, and then this number times that number. I multiply the percent abundance times the atomic mass for that isotope, and then I get numbers, okay? But you have to remember that these are percentages, so you have to move the decimal 2 places over before you do your calculations, okay? So the decimal is going to be there in the front. So when I multiplied 0.60108 times 68.926, I get a number I didn't put correctly in the calculator. Ha ha ha. Let's try it again. Okay. 41 point, I actually did put it in 0.430. I know you can't see this, but it's 00401. So I'll write it down here. 41.4300401 for the first one, and then for the second one, 0.39892 times 70.
Please pay attention to the following announcements.
0.925.
Monday at 2:45, right after school, there will be a meeting for anyone interested in playing softball this year. Please make sure you get your athletic packets turned in ASAP. Seniors, you're now dismissed.
I'm glad that was fast. Okay, so then when you're done, you have two numbers, the first number 41 and the second number 28.29 off the page there. And you add these two together. Notice how I did not reduce these. I did not round these yet, okay? Because we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Our answer, we know, has to be 5 significant figures, but I didn't round it yet because we need to round it at the end, okay? So if I add these two numbers together, I get 69.7234411. Now, you can see that this makes sense because it's in between these two isotopes. That's where it's supposed to be. It's supposed to make sense, all right? If it doesn't make sense, if it's some weird number, you did some math wrong up here. So, and now it needs to be 5 digits. So remember what our rules about significant figures. You underline the 1, 2, 3, 4, 5, and you put an arrow there, right? If you can't do this in your head, and then that's not a 5 or higher, so that just remains a 3. So your answer, therefore, is this. And you should start putting boxes around your final answers on your papers so that I can determine what the proper answer is. And the units are AMUs. Okay, 69.723 AMUs. And to check it, you'd go on the periodic table, and sure enough, that is the average atomic mass for gallium. And number 6 and number 7 on the assignment are done exactly the same way. There's no difference in what you're supposed to do. Everything's the same, okay? Number 8, however, is a little trickier. So number 8, you needed to do some research, and we'll discuss that one in class. That's fine. We'll discuss number 8 in the classroom. Okay, and then number 9, we'll discuss that one too. So 8 and 9 we'll discuss in the classroom. Okay. All right. Any questions? Feel free to contact me.